Hi, I'm Kian, and I'm back with an interesting question. In my previous videos, I have used the generalized pi function, which is represented by this improper integral from 0 to infinity of e to the negative t times t to the power of x dt to calculate factorials. But have you ever think if you can use this to evaluate negative factorials, like negative 1 factorial? That doesn't seem a reasonable answer, doesn't seem to have a reasonable answer. But let's try. If we evaluate the pi function, which is usually used for evaluating factorial at -1, we get a very nice improper integral. We get the improper integral from 0 to infinity of e to the power of negative t, and then times t to the -1, which is the same as over t dividing by t, and then dt. I'm going to write this integral as negative, and then the improper integral from 0 to infinity of negative e to the negative t over t. Now you can see I have labeled this integral. This improper integral is a very famous integral known as the exponential integral, which is labeled as ei of t in this case because our function notation is t, our variable is t. But it's a very famous integral, it's exponential integral, and there are various integrals such as like sine x over x is six. This is another type of special integral that we analyze in calculus and is known as the exponential integral. So we have the answer to this integral is just negative ei of t, but we should evaluate this integral from 0 to infinity. Now, we can't evaluate a function at infinity because infinity is just a limit. Infinity is just is not a number. Numbers approach infinity but never equal infinity. So we should take a limit of this function. So I have prepared a rough sketch. It's not a very accurate sketch, but it represents our main point. And I want to take the limit. So for the limit as x goes to infinity of ei of x, or t goes to infinity, doesn't matter. We have just changed the variable. The right hand limit and the left hand limit should be equal. So what I mean is that in this case, when the x grows faster to the right as x approaches an infinity from right, what we can see is that uh, uh, as it goes faster from right, it goes to positive infinity. What it means is that as x gets larger to positive finite values, it grows very fast. And oppositely, when we evaluate the limit as it goes to negative infinity from the negative side, it strictly goes to negative infinity. But negative infinity and positive infinity aren't equal. So the limit actually doesn't exist. So ei of t at infinity actually doesn't exist. And ei of 0, it doesn't matter. I think it's equal to 0.5, but you can check because this is not really very accurate sketch. But it doesn't matter because when we found that at infinity it's doesn't exist, we know that the whole thing, we can conclude that the whole thing is just divergent. Oh, let me write it again. So the integral diverges. So we know that there is no finite value for -1 factorial. Divergence. And that's it. Thanks for watching.